Today we'll be demonstrating how to set up and use a CM140 system from UIC Inc. to perform a total inorganic carbon analysis by acidification and coulometric detection. Pre-scrubber. Carefully unpack all the glassware. We will start with the pre-scrubber. Unpack the pre-scrubber body, dispersion tube, and the black threaded bushing with the O-ring. Place the O-ring supplied with the black threaded bushing over the open end of the dispersion tube and insert this tube into the pre-scrubber body. Adjust the O-ring on the dispersion tube so that the tube is just above the bottom of the pre-scrubber body and tighten the threaded bushing over the dispersion tube to seal the entire assembly. Place the pre-scrubber in its designated place on the left side of the acidification unit. Post-scrubber. Unpack the post-scrubber body, post-scrubber top, and the red joint connector. Set the threaded joint connector on top of the post-scrubber body. Place the post-scrubber top into the connector and screw to tighten. The outlet of the post-scrubber top should be positioned 90 degrees from the post-scrubber side arm. Position the post-scrubber assembly in the clips on the right side of the acidification unit. Sample column assembly. Unpack the 3-finger sample column adapter, condenser, threaded fitting, Teflon ferrule, and red joint connector. The septum normally comes inserted in the 3-finger sample column adapter, but if that is not the case, insert the septum in the top opening. Fold down the sides of the septum over the glass lip of the sample column adapter. Place the red joint connector on top of the condenser and join the 3-finger adapter to the condenser while sliding the Teflon tubing through the condenser. Tighten the red joint connector. The threaded fitting and Teflon ferrule will be used later to connect the acid dispenser to the sample column assembly. Place the whole sample column assembly on the acidification unit by positioning the 3-finger clamp between the 2 side arms of the condenser. Acid dispenser. Assemble the acid dispenser as follows. From the box, take out the acid dispenser, telescoping dip tube, and the appropriate adapter fittings. Use the adapter fittings to connect the acid dispenser and the bottle. Before connecting the bottle, attach the telescoping dip tube to the bottom of the acid dispenser. The end of the dip tube that has 2 holes should be at the bottom, in the bottle. Place the stainless steel beaker into the acid dispenser well on the acidification unit. Place the acid dispenser assembly into the stainless steel beaker. To connect tubing from the acid dispenser to the 2nd finger of the 3-finger adapter, use a Teflon ferrule and threaded fitting. There are 4 different types of sample flasks: 10, 25, 50, and 100 milliliter, with appropriate inserts for the heating block. 100 milliliter flasks do not need an insert, they are placed directly into the heating block. For this demonstration, we will use 25 milliliter flask and insert. Place the insert in the heating block. Connecting components of the acidification unit. Find and open a bag with Teflon tubing from the additional parts box. Use small unions to connect tubing to the glassware. Check the length of the tubing and cut to allow the 3-finger adapter to move in and out of the heating block. Attach the side hole of the pre-scrubber to the upper finger of the 3-finger adapter. Check the length of tubing to cut and connect the lower finger of the 3-finger adapter to the side arm of the post scrubber. Connect tubing coming out of the acidification unit to the top of the pre-scrubber with a small union. Connect the top of the post scrubber to the coulometer cell via a check valve. Trimming Teflon tubing from the sample column assembly. Hold the sample flask next to the completed sample column assembly to determine how much of the Teflon tubing to trim off. Trim tubing at a 45-degree angle, not horizontally. Trim the tubing so that, when assembled, the tubing will be within a few millimeters of the bottom of the sample flask. Attach the sample flask to the sample column assembly using one of the red threaded joint connectors. At the front of the acidification unit, we have a power switch, lift switch for moving the arm up and down, and carrier gas switch to choose between internal air pump and external nitrogen gas tank gas sources. Connection for the external gas source is in the back of the acidification unit. This is a temperature controller. To adjust temperature, press and hold the left button and use the middle and right buttons to lower and increase temperature, respectively. Set the flow meter to 100 milliliters per minute. Only the coulometer should be connected to the power VAR, even though it has 2 outlets. We'll begin with screen calibration. Follow the instructions on the screen to calibrate. Screen calibration should only be done when users change. Setting parameters. Select System Parameters. Change settings. Here you can choose the form you'd like your final results to be calculated in. If you choose carbon, the results will be presented in the form of %C, %carbon, or you can choose %CO2 or %CO3. Here, based on the type of your samples, you can choose initial sample measurements entered by weight, volume, or units only. If the units only option is selected, results will be presented as amount of carbon in micrograms. The units range from micrograms to milligrams or grams. Here we choose milligrams. The percent difference criteria is 0.1% by default. This is the number the system uses to decide when to stop. The system takes a sample reading every 1 minute by default, compares the last 2 readings, and if the difference is less than 0.1%, the measurement stops. Factor is used if you have some diluted or concentrated samples. You can enter a factor here so the system will calculate and give you the final values. Number of readings is the minimum number of sample readings the system will take per sample. In this case, we chose 8, but this number can be any number higher than 2 and lower than 45. This is the number of readings the system will do without using the percent difference criteria. After running this many readings, the system will start comparing the last 2 results to decide when to stop. Interval is the time in between sample readings. The default is 1 minute, but you can increase or decrease the interval. This will affect total measurement time for a sample. Timing method. If auto endpoint is selected, the system will use previously set percent difference criteria to decide when to stop. If fixed number of readings is selected, then the system will only run the number of readings you selected previously. In our case, we chose 8 readings, so the system would take 8 readings for each sample and then stop. Sampling method. You can choose auto sampler if you have an auto sampler. Otherwise, choose manual if you have a manual acidification unit. Printout format. Choose standard format here. The calibration test format is only used to check if the electronics are working. Sample entry method. Information about samples, such as sample names and weights or volumes, can be entered from the USB disk or manually. Here, Analyst ID and Instrument ID can be changed. This is convenient if you have more than one user. When finished, press F4 to get out. When you press back, the system will save the changes on the USB and return you to the System Parameters screen. Print settings. Even if the printer is not attached, you can select this to view the parameter data. Press F4 to get out. Setting date and time. Press 1 to enter the date and press 2 to enter the time. Press F4 to return to the System Parameters page and press back once more to save all the changes on the USB. Preparing the carbon coulometer cell. The cell has 2 compartments. The larger one is the cathode compartment and the smaller one is the anode compartment. There are a few steps to preparing the coulometer cell. Step 1. Place the magnetic stirrer in the cathode compartment. Step 2. Fill the anode compartment's lower bulb with potassium iodide until it is about 1/4 to 1/3 of the way full. Step 3. Using the gallon jug of cathode solution, fill the cathode compartment up to the 100 milliliter line. Step 4. Using the smaller sized bottle of anode solution, fill the anode compartment until it is slightly less full than the level of the cathode compartment. Step 5. Put the tops on the compartments. The cathode top has a platinum electrode and an inlet tube. The anode top has a silver electrode. After putting both tops on, adjust the heights of the platinum electrode and the inlet tube so that they do not interfere with the magnetic stirrer. You may have to lift the electrode and the inlet tube slightly or lower them down if necessary. Both the platinum electrode and the inlet tube should be just slightly above the magnetic stirrer. Step 6. After adjusting the heights of the inlet tube and the platinum electrode, turn the cell to adjust the cathode top. You want the platinum electrode in the inlet tube to be as far away as possible from the light path going through the bottom part of the cell when it's placed in the coulometer. To do that, Make sure that the top of the silver electrode on the anode compartment is in between the inlet tube and the platinum electrode from the side angle. This ensures that the platinum electrode and the inlet tube will not interfere with the light path. Step 7. For the final step, take a clean Kim wipe with a small amount of methanol and wipe the sides to remove potential fingerprints or any other residue that will interfere with the light path. Now the cell is ready to be placed in the coulometer. Place the cell into the cell compartment of the coulometer. Before connecting, check that the cell current switch is in the off position. While the switch is off, connect the cathode using the black connector and the anode using the red connector. Then place the inlet tube and the outlet tube through the holder on the right in this case. The holder can be moved on the left if the acidification unit is placed on the other side. Now the cell is ready to be titrated. To connect the coulometer and the acidification unit, connect the inlet tube of the cell to the acidification unit with the tubing coming out of the post scrubber. The check valve ensures that the carrier gas moves in one direction, towards the cell. When the cell is placed in the coulometer and connected, the cell current button is still in the off position, the acidification unit is working, and the carrier gas is going through the cell, you can go to Run Cell Setup. The system will use this number to determine 100% transparency. You can move the cell slightly left or right to maximize this number. The number should be between 2700 and 4000 and stable within 10 digits. At this time, it is best to leave the system 5 to 10 minutes to stabilize. When the difference is less than 10 digits, press Next. The system will regard the final number as 100% transparency. Titrating the cell. Press Start Analysis. In this step, we'll titrate the cell down. The cell should be at 100% transparency, and the cell current should be 0. Flip the cell current switch to the on position. The cell current should change to 200 milliamps, and the transparency should begin decreasing. The cathode solution will slowly change color and become bluer. The percent T number should decrease to 29.5% plus or minus 0.1. When it does, the titration is complete. While waiting for transparency to decrease, we recommend leaving the coulometer 45 minutes to an hour, even though 29.5 will be reached relatively quickly. This leaves enough time for the system to stabilize. After waiting for this period, the cathode compartment's contents should be blue, percent T should be 29.5, and the system is stable and ready. After that, press Next. Here we can enter how many samples we want to measure. Be sure to include the blank measurement in your number of samples. You can enter all of the samples and their information now, or you can enter them one by one. To enter one by one, enter the first sample and press Next to enter the next sample. For example, we enter 1 and begin the first sample. Remember to always start with a blank sample by selecting blank. Now the system is ready to begin analysis. To start the measurement, press Begin Analysis and then pump acid into the sample column assembly. Displayed here we have sample name, %T, cell current, total amount of carbon in micrograms measured, and the elapsed time. There is also a button to abort sample. All the measurements will be listed in these fields here. When we press Begin Analysis on the display, it's time to pump the acid. Slowly pump 10 milliliters of acid into the system. You should see the acid enter the system and the carrier gas begin bubbling through the acid. The sample column assembly can be lowered into the heating block if you want to use heat to assist CO2 release. The system will be almost finished with measuring blank. We set the system to do 8 readings, which should take 7 minutes because the first reading is at time 0. When it finishes, we can see that the blank sample is 1.5 micrograms of carbon. Any value between 0 and 10 micrograms of carbon is acceptable, but this range varies between different analysts and types of samples. If you would like to measure more samples, press Next. If you are finished, press Done. To change samples once the blank is finished, press Lift Up, unscrew the red joint connector, and slowly pull the flask down. Use a clean Kim wipe to wipe the tubing for any acid that might be left over on the outside, and if you see bubbles of acid on the inside of the tubing, flick the tube a few times to get rid of the bubbles. This sample was weighed in a Teflon cup, and the cup was placed in the flask. Attach the flask to the sample column assembly with the red joint connector, and you're ready to start the next measurement. When the new flask is in place, press Next. Enter your sample name and size and press Enter. We can see that the %T is slightly elevated because there's trapped CO2 from the air that was inside the flask. The system will purge that and the %T will go back to 29.5. When this is done and the cell current is 0, the system is ready to begin analysis. To begin sample analysis, press Begin Analysis and pump acid into the sample column assembly. If you notice that there's a bubble in the Teflon cup, tap the flask gently before placing it in the heating block. The system will measure until it reaches % difference criteria, and then it will stop. At that point, you can press Lift, then change the sample flasks and put another sample in. When sample measurement is finished, you can see the results on the screen. For this sample, the measured carbon content is 12.04%. The theoretical value is 12.01%, so this is a good measurement. If you have more samples, you can press Next and measure more samples. Or, if you are finished, you can press Done, and then the system will save these results on the USB. Our systems are equipped with a safety button located on the UIC logo. If you remove your USB drive and are unable to see your results on the drive, you can put the USB back and press the circle in the logo to save the last set of measurements again. This function only remembers the most recent set of measurements, so do not run another analysis before checking your results, because then that analysis will be saved instead of the previous one. Shutdown of the system. When you are finished with measurements, or finished for the day, disconnect the acidification unit from the cell and coulometer. Switch off the acidification unit, switch off the cell current, and then switch off the coulometer. Remove the cell and dump the solutions, and then clean the cell so it's ready for the next time you do measurements. Thank you for joining us for this demonstration of a CM140 system from UIC Incorporated.